So we saw that one problem, which is capturing diverse direction semantics, is handled by bidirectional RNN. But basic idea of long range memory, which is a main drawback because of vanishing gradients problem, is primarily handled by a complex architecture called LSTM, also known as long and short-term memory. So LSTMs are usually endowed with a slightly more complex internal architecture of every node, which enables them to give each cell something known as a state. So each cell state can have multiple dependencies. We will look at basically three kinds of gates which are helping LSTMs to get a more complex structure and thereby endowing it the long-term memory as compared to a conventional RNN. So what the LSTM inventors wanted to do was, the inventors, Operator and Schmidt-Humer, they wanted to create an architecture where RNNs can remember things for a long time. And that's what we meant, right? When we talked about, okay, he went to France, it is possible that the people there are speaking Dash. So the French prediction should be based on something which is 3 or 4 words away from the current context. So what they did is they designed a memory cell which is not purely based on the conventional neuron, which is, what is a conventional neuron? Based on some sigma of wi xi passed on to an activation function. Instead, they used both the sigmoid and linear units and added some specific electronic gate interactions so that you can impart memory to the cell and it can retain memory inside the cell. At the highest level, there are thinking about 3 phenomena which the cell has to perform. One is you should be able to get the information into the cell, which is what we call as writing to the cell. Then information which is in the cell should be retained, which is what we call as a keep. Then information in the cell can be read for future cells, which is what we call as a read state. So it is these 3 phenomena which are important for the perspective of giving the notion of memory to the particular cell. So if you look at, for example application, say stock price of today, it could be basically depending upon the trend in the past few days, it could downtrend or an uptrend. So price of stock on the previous day is also a big determinant. Then there is also possibility that there are some current policies which are changing the current input data. So for any problem, we define the influencing factors for a current cell state as whatever was the previous cell state, means whatever was present in the memory of that current cell state. Then whatever is the output of the previous state, which is the hidden state, linked to the current cell, which is basically output of the previous cell. And at the current input step, whatever is the new information that is influencing it. So this is basically influencing ideas which have come from the way people have been modeling time series. If you remember the way time series problems have been tackled in earlier versions before machine learning and deep learning came into vogue, there was always, you know, three kinds of, influencing factors. One was what we call as a trend, which was a long-term trend. Then there would be something known as seasonality, which would be based on very local behavior compared to the nearest inputs. Then there would be, actual local perturbations or local varying function, which would determine the way the time series would behave. Accordingly, the same three concepts have been brought here. So the idea is any problem now will require us to model what is the function which is combination of these three things. In taking input from previous content of the current state, then the output of the previous hidden state, and whatever is the current input being fed to the current state. So just because of these three properties, we are able to forget or remember things in LSTMs depending upon the use case and the data that is fed.